many ways are there to solve math?
Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solve perimeter is?
2 times length plus 2 times width.
Welcome to Count on Us. I'm Shari Sternberg.
And I am Mrs. Davis, your Telly Award-winning math homework hotline.
And we are so happy that you're here joining us. We want to let you know how you can contact us. Our number is
301-772-0080. Call now. We're waiting to hear from you. Pick up the phone and dial those digits. Again, they are 301-772-0080.
You can also reach us by email. You can send us an email problem and we'll have students helping you solve your problems. That's kind of cool to watch another student solve your problem. You can send us an email at
COU@PGCPS.org. And if you are watching us on television, that's fine, Comcast or Verizon. But if you have DirecTV, you can watch us on the World Wide Web.
Oh, cool.
And across the nation on the web.
Woo.
www.pgcps.org and click on Students and Homework Help, and you'll find us there.
Oh, well, and you'll also find us right here, ready to help. And we're going to help you when you call in with your homework, but we also want you to do a couple of things. Those are called our challenges. We have 2 challenges for you today. The first one
is the word scramble. In mathematics, vocabulary is just as important in reading. So we have a word scramble. The way that this is going to work, you are going to ask us a yes or no question as a clue, and we'll say yes or no, and then you are going to guess what this word is. So if you can unscramble it to give you a mathematics term, that would be the word scramble. And we have our old faithful, the 24 challenge.
24 challenge. It says exactly what it does. It challenges you to get 24 using the 4 numbers on each individual card. So card A has the digits, and write these down so you can be working on it while we're helping other people solve problems. Has the digits 1, 2, 7, and 2. So you have to use all of them, and there are 2 2s here, so you have to use both 2s.
And card B, this is shaded in, so that means it's a 9. So this is 9, 8, 8, 7. And again, since we have 2 8s, that means use both 8s in solving.
And speaking of both 8s, we have 2 8s on card C as well. So jot these down, 8 and 8, 4 and 7. So maybe if you solve this one, it might help you. Not saying it will, definitely, but it might help you solve this one.
Yes. And
Excellent.
you do want to look for patterns as you're solving the 24 challenge. And card D, 1. Now notice that this is not shaded in. So this is a 6, 6, 4. Again, we have a lot of doubles
There's
on
our
all
pattern.
of them.
Every card has a double on it.
So that means you're going to use that digit twice.
Excellent.
So please jot these down so that when you give us a call, you can challenge yourself. And I do think we have a caller already there. We love our callers, both our first-time callers and our frequent fans. So in addition, we're going to offer you one more challenge. We're going to challenge you to have your friends call in to get math homework as well. Again, the number is 301-772-0080. And we have a caller.
All right, so we have Jade on the line. Hi, Jade.
Hi.
You're from Glendale Elementary School?
Yes.
Welcome. Now, I'm hearing myself behind you on the TV, so we need Jade and anyone who calls in to make sure you talk to us on the telephone and listen to us on the telephone, but not on your TV. So turn the volume all the way off, mute the TV.
Okay.
All right,
All
so
right.
you did that already? Nope, because I just heard myself again. So did you turn the TV volume down? All right, Jade is from Glendale. What school are you in?
Hello?
She's back. Hi, Jade. So what grade are you in at Glendale Elementary School?
I'm in 5th grade.
5th grade, okay. I know 5th graders are working on multiplication and fractions. They're working on order of operations. They're doing some division as well. What can we help you with?
Order of operation.
Hey, order of operations. I like it. Tell me what numbers we're working with. What does the equation look like, or the expression?
3 parentheses 6 plus 2 parentheses minus 12 times 2.
Excellent. So, tell me what you know about the order of operations.
Well, I know. Well, our teacher gave us a code.
A secret code. Now, you're on national television, so let's see if you can reveal the code to everyone. Because one thing about education, we like to share the secrets. So tell us what the code is, Jade.
It's PEMDAS.
That's the code. And it's not a secret code, as I said, because in education we want to share our codes. So tell me what each of those letters stands for.
It stands for. Hold on. It's
Up. She's looking it up. I think she forgot some of the code. What parts do you remember? We can help you fill them in.
parentheses.
The P is parentheses, and we have those. Then the E is?
Exponent.
Exponents. And exponents are those little numbers up top that tells you that's how many times you're multiplying the same number. We don't have any of those, so we don't have to worry about exponents today. And what does the M stand for?
Multiply.
And the D?
Divide.
Divide, because I'm putting those next to each other, even though some people write them in a row, because we're going to do multiplication and or division after we look for exponents, but whichever one of these comes first is the one we're going to do. So we don't have to do multiplication first. We could do division if that's first. And then the AS stands for?
Addition and subtraction.
You got it. Addition, oops, and that's division, and that's subtraction. Excellent. So we said we had parentheses. So when we solve problems that use the order of operations, it's important that you do each part and write each part as you're going to help you remember what you've done so far. So we're going to move the parentheses and exponents. We're going to move those along a drip. Parentheses and exponents, and I'm going to say we have parentheses. What's first?
You do 6 plus 2.
6 plus 2. They're in parentheses. How much is 6 plus 2?
6 is 8.
Is 8. So now we have 3 times 8 minus 12 times 2. Okay? Now,
Okay.
what do we do next? We have no exponents, so we're going to do our multiplication or division.
We're going to do multiplication.
Because we don't have any division, right?
Yeah.
So we have 3 times 8. How much is 3 times 8? I can hear you count it, so I'm going to wait a quick
24.
moment. 24. 8 plus 8 plus 8. And now we have a subtraction sign. Do we subtract now?
Yes.
No.
No.
Just look over here, even though there's no parentheses.
Multiply.
Exactly. We have to do all of the multiplication and division. So now we're going to multiply 12 times 2.
24.
24, and we still now have that subtraction sign. How much is 24 minus 24?
0.
0. If you don't do order of operations correctly, let's say you knew this part. We do parentheses first. 6 plus 2 is 8. 3 times 8 is 24. But if you then subtract 12 from it, you'll get a 12. Actually, this one does work out the same way, coincidentally, I think.
12 times...
Because you're going to get 12,
2.
and then 12 times 2, we'll still get 24.
But not our
Oh,
answer
that's right,
of 0.
That's right. Okay, that's what I was trying to prove. Thank you. So, we would get 3 times 8, and if we subtracted a 12, 24 minus 12 would leave us 12, and then times 2 would be 24. So that's the difference of having a 24, which is not correct, and a 0, which is correct. So we want to make sure we learn our order of operations, okay?
Okay.
Great job, Jade.
And Jade, we have put your name into our treasure chest
Woo-woo.
because we treasure all of our callers. Now, Jade, I have a quick question. Are you a first-time caller or a frequent fan of Count on Us?
Well, this is my second time calling.
All right.
So you're becoming a frequent, faithful fan.
All right, Jade. I'm going to shake the bells for Jade for tuning in. And you know, if you'd like to do a challenge, we're going to ask you to give us a call back because we do have one other caller waiting. And do you have any friends that you would like to challenge to call in as well?
I would like to challenge Shakira to call.
Shakira, I hope you're listening because you have been challenged by Jade to call in. So we're going to be listening for Shakira to call in.
And you know what? If you get a friend to call, we're going to put your name in again.
All right, Jade.
We're going to give you another chance. So anyone who says, oh, I was referred by such and such who's called, then we're going to get your name in there again. But we have another caller, so let's go to it.
All right, caller, are you there?
Hello?
Hi. Welcome to Count on Us.
Oh, I hear 2 of you.
All right. Is this Darren? Hello?
I think you just turned the TV down. Coming back to us, Darren?
Hello, caller, are you there?
Oh, no.
All right. Well, we were just going to say that when you call in, you can get it after you've asked your question. You can do a 24 challenge. And you know, today is a very, very special day across the United States of America. We're celebrating the actual birth date of an outstanding American. And I'm challenging you to guess who that is, Miss Sternberg.
You're challenging me? I think we want to give our callers a chance to think about it.
Okay, so I'm going to give you a clue. If you call in, when you call in, if you're able to tell me whose birthday it is, an outstanding American whose actual birthday is today, and on Monday we will be celebrating as a national holiday, doing acts of service. So Monday is an act of service day representing the service that this particular individual made to the United States of America.
Awesome.
So I'm challenging all of our people who are listening out there. Do you know who this outstanding American was? And today is his actual birthday. So we're going to say happy birthday after you tell us who it is.
All right. So even though you had a caller that was about to call in and we lost him, you wrote down multiplying fractions. Did we want to talk a little bit about multiplying fractions, or you have to go first?
I was going to stick this back up in case some callers are just tuning in and they did not get a chance to see the challenge. Our challenge questions again, so you'll have an opportunity to jot these down, our 24 challenge. And again, the challenge is to get a total of 24. So card A was 1, 2, 2, 7. Card B.
We have that filled in bubble up here, which means it's a 9 when it's heavier filled in. 9, double 8s, 8, 8, 7.
And card C, again, double 8s, 8, 8, 7, 4.
And the last card, card D, jot it down, 1, 6, 6, 4. 1, 6, 6, 4. And one thing I always like to point out about these Challenge 24 cards, I love doing Challenge 24 myself because I like to be able to manipulate numbers in my head. But my challenge to myself is to see how many different ways I can solve it with one card.
Oh, that is a good challenge.
And there's very few cards, very few where I haven't found at least 2 solutions.
Oh, yeah.
Every single card I've done, except for one I got stuck on. But every card has at least 2, and I found 3 on some cards where we've been able to solve the problem 3 different ways. Now, I'm not talking about using the commutative property where we say 8 plus 7 is 15 and 7 plus 8 is 15. I'm not talking about that. I'm talking about legitimate different computations to get to the solution.
Okay, and I'd like to also put back up our word scramble challenge. And at the beginning of the show, we stated that vocabulary is equally important in mathematics as it is in reading. So these math vocabulary words help to unlock the meaning of the problem and make you think about particular things. So you're going to use these letters right here to unscramble to come up with a math term.
Sounds good.
All right, so we're waiting for our caller to return. We're so sorry we dropped the caller, but let me look. I think I might see somebody else tuning in. Is this Terrell?
Hello.
Hi, Terrell.
How you doing?
Fine, thank you. Welcome to Count on Us, and thank you for joining us today. Can you give a big shout out to your school?
Ernest Everett Just Middle School.
All right, welcome. And what grade are you at Ernest Everett Just?
8th grade.
Okay, and are you working with fractions?
Yes.
Okay, well, we will try our very, very best to help you out. What exactly are you doing with fractions?
Multiplying them.
Multiplying fractions.
You must have had a premonition because that's what you have written right over here on the piece of paper.
Okay, so can you give us the fractions that you're actually multiplying, or is it in a problem context?
You say that again?
What is the question that you'd like some help solving?
3/8.
I'm sorry.
3/8 times 11/16.
3/8 times 11/16. Okay. Take a look to see if I've written the problem correctly.
Yes.
Is that correct?
Yes, it is.
Okay, 3/8 times 11/16. What do you know already about multiplying fractions? Do you know anything at all about multiplying fractions? That might be a good starting place for us as we work through this together. Okay. All right. So when we're multiplying fractions, if we're following a procedure, we're just going to multiply numerator times numerator, denominator times denominator to come up with a solution. And then look to see if we can simplify. So let's see if we can do that.
Okay.
So if I multiply 3 times 11, Three times
33.
Very good, 33. And if I multiply 8 times 16, let's line that up and multiply. 8 times 6 is that 48? 8 times 6, is that 48?
Yes, it is.
Okay, so I'm going to put down my 8 and regroup my 4. And 8 times 1 is?
8.
8. And then I'm going to add on my 4 that I regrouped from 48.
And that's 12.
And that will give me 12. Okay, so my numerator is 33 and my denominator is 128. And we're going to look to see if we have any common factors between 33 and 28. So if I'm looking at both 3 and 11, both of those numbers are prime.
Mm-hmm.
So there's no common factor between 33 and 8 times 16 gives me an even number, so I have no common factors. This is what is considered a proper fraction, so I don't need to rename it as a mixed number. So actually my solution is just 33 128ths. Okay?
Uh-huh.
Okay, does that help?
Yes, it does.
All right, fabulous. Thank you so much for joining us today. So I have a question. Is this your first time tuning in?
Yes.
All right. Well, that means we have a first time caller. So we have another question. Since you're a first time caller, do you have any friends that you would like to challenge to call in to Count on Us as well?
Yes.
Who would you like to challenge to call in to Count on Us?
Tariq Turnerseed and Jonathan Breedlove.
Okay, Tariq and Jonathan, you have been challenged to call in, and your name is going into our treasure chest because we treasure all of our callers. So stay tuned until the end of the show to see if you are indeed a winner of a fabulous prize.
Okay.
Did you want to try one of our challenge questions?
Yes.
All right. I love it, love it. So, in case you did you get a chance to see the two challenges we were working with?
No.
Okay, so if you'll look right here, this is a word scramble. This is a word, a math vocabulary word that you could unscramble these letters to get it. Or we have something called a 24 challenge. Are you familiar with the 24 challenge at all?
One of them should equal up to 24.
Yes, you're going to use all four of the numbers on the cards so that the total is 24. And you can add, subtract, multiply, or divide, or any combination of that so that you get a total of 24.
Uh-huh.
Okay. And would you like to try one of those?
Can I call back and try to do one?
Oh, yes. Which one would you like to try? And we'll stay tuned to help you out.
D.
D as in dog. Okay. And notice that there are dots here. Sometimes that signify a more challenging card. So 1 dot is challenging. 2 dots is a little more challenging. And 3 dot is sometimes considered the most challenging. So I love the way you have chosen to challenge yourself. Now, Terrell?
Yes.
We also put out a challenge to say that today is a very important American's actual birthday. This date in history.
Martin Luther King.
Martin Luther King Jr. Absolutely. So, Terrell, your name is going in for a second time. Whoa. Knowing that today we are celebrating the actual birth of Dr. Martin Luther King Jr. And across the nation, individuals will be doing acts of service in recognition of the outstanding service that Dr. King provided to the United States. All right, Terrell, so you're going to have an opportunity to jot card D down. The numbers are 4, 1, and since this is not shaded in, this is 6 and 6. So you're going to use 2 6s, a 4, and a 1 so that you come up with a total of 24, okay?
So it's 2 6s, a 4, and a 1?
Yes, 2 6s, 4, and a 1. When it's shaded in red like this, this means this is a 9. But right here, they're not shaded in, so that means that is a 6. Okay?
Okay.
So you're going to give us a call back?
Yes, I will.
All right, and we're going to wait to see if we hear from your 2 friends that you challenged to call in as well. So thank you so much for your call today, Terrell.
You're welcome.
All right, so while we're waiting for some other callers, I think it might be a good idea to visit a little bit with multiplying fractions, because as we saw, some of the older students in middle school are doing multiplying fractions, and so are our 5th graders and some of our 6th graders as well. He had a fraction that we didn't have to do any simplifying with because he had prime numbers on the top and there was no common factor of any of the numbers in his numerator or denominator, so there was no simplifying. It was in simplest form. Let's look at another fraction. How about, let's get a working marker, how about 5/10 times 3/7?
3/15.
Want to go with 3/15? Is that what you're saying?
If you want to do some cross-canceling.
Okay, we can, well, wait, let's look at that next then.
Okay.
All right? Because we might have some time to look at that.
Okay, we might.
All right, so you're using the same strategy when you're multiplying fractions each time, and we're going to look at I mean, sometimes there's other strategies, and we'll talk about that in a minute. But if we look at multiplying our numerator times our numerator and our denominator times our denominator, 5 times 3 is
15.
And 10 times 7 is
70.
70. Now, when Terrell was done with his problem, because we couldn't do anything to simplify, make equivalent fractions that are smaller, he was done. But here we can. And I actually know we can for 2 reasons. How do we know this is not in simplest form? What are you thinking?
I'm looking at it, and it looks like it's pretty big numbers, but I remember from last time we had pretty big numbers, and it was in simplest.
33, 100 somethings.
Okay, so I'm looking here. I'm probably thinking about my divisibility rules. That really helps out a lot. And if I'm looking at my divisibility rule for my denominator, I see that it ends in 0. And I know that any number that ends in 0, there is a multiple of 10, which is what we used. There is also, it is a multiple of 5. And it is also a multiple of 3. So I can use 10, 5, or 3. Or even, I'm sorry, not 3. I'm sorry. I misread.
You started that curve, and I thought you were going there.
2. I'm sorry.
All right.
2. So not 3, but 2. We have another strategy to use for 3. So 70 is a multiple of 10, 5, and 2. So we're going to do the same thing with our numerator to see what it ends in 5. So we can think about our divisibility rules. And anything that ends in 5, and I'm writing backwards. Anything that ends in 5 is a multiple of what number?
5.
5. Okay.
Because 5 is a prime number.
Yes, 5 is a prime
So 1
number.
and 5, and all our numbers have 1. So we kind of didn't put that. That's kind of understood that every number has 1 in itself. Mm-hmm. But 5 has a 5. And I see 10 has a 5.
So since this is the same common multiple between the same common factor, same common factor between both of my numerator and my denominator, then I can use that to simplify this particular fraction.
So let's do it. Simplify means we're going to divide both of them.
I don't know if you have more space down there.
We'll come over here, rewrite it. We're going to divide both of these by 5. And 15 divided by 5, and I love to, when I have the same numerator and denominator, put a 1 around it, because we know that they're 1s. 15 divided by 5 is?
3.
And 70 divided by 5 is?
I'll have to think about that a minute. Let's see, 5 divides into 7 1 time, with 2 left over, and 5 divides into 20.
0, yep.
4 times.
4 times.
So now we're going to check to see if there's another common factor between 3 and 14.
And 1's an odd number, 1's an even number. That's not always the reason, but that right away I see.
And 3 is prime. So the only factors are 3 and 1.
And 14 doesn't have
a 3
exactly
as a factor at all.
So
I'm sorry.
I was just going to say, we looked at a multiplying a numerator and denominator that didn't have simplifying. We simplified. We're going to take a caller, and then we're going to come back and talk about cross-multiplying.
Ooh, sounds exciting. All right, I think we have another caller. Caller, are you there?
Hello?
Hi, welcome to Count on Us. Can you please tell us your name and the school that
Salafina.
Salafina. I have a friend that frequently calls that's named Salafina. Wait a minute. Is that you, Salafina?
Yes.
Oh, welcome back. It's such a pleasure to hear from you today. How can we help you?
I had a question on multiplying mixed numbers.
Multiplying mixed numbers. Okay.
My problem was 2 and 1/2.
Okay. 2 and 1/2.
Times 10 and 1/3.
Times 10 and 1/3. Okay, I'm going to write your problem down, and I need you to let me know whether I've written it correctly. You want to multiply 2 1/2 times 10 1/3.
That's right.
Okay. What do you know about multiplying mixed numbers?
Well, before you multiply mixed numbers, you have to change them into improper fractions.
Okay. Well, can you help me out with that? How do I change 2 1/2 into an improper fraction?
You have to multiply the denominator by the whole number.
Okay. So that's...
And then add the numerator.
Oh, I love the way you are using your math vocabulary. You are attending to precision.
Keep the denominator the same.
Keep my denominator the same, which would be 2. And what about my numerator?
It would be 5.
5. Okay. So, now what?
You would have to change 10 1/3 into 30 1/3.
Okay. And again, you multiplied 10 times 3, which was 30, plus 1, which is 31. 31 thirds. All right.
It was 3. I thought was it 1/3 or one? It was 1/3.
So now, are we ready to multiply?
Yeah.
Okay. So we're going to multiply numerator times numerator, denominator times denominator. Okay, so if I'm multiplying my numerator, I'm going to do the denominator first because that's easier. 2 times 3 is?
6.
6. Okay, now 5 times 31. I'm actually going to rewrite that so I can line up my digits.
It's 155.
Oh, very good. So 5 times 1 is 5. 5 times 30 is 150. 155. Okay, now, do you think we have completed our work? Can I see any raise?
No.
Okay, what else do we need to do?
Well, you have to divide the denominator into the numerator.
Love that vocabulary. Divide the denominator, which is 6, into the numerator, which is 155. Okay.
6 goes into 15 2 times.
Oh, love it. And what is 2 times 6?
12.
12. Now what?
So you subtract 12 from 15 and you get 3.
Very good. Am I finished?
No, you have to bring down the 5.
Okay, bring down the 5. 6 divides into 35.
5 times.
5 times 6 is?
30.
30. Subtract.
You get 5.
5. I've run out of numbers. Now what do I do?
Your whole number would be 25.
My whole number would be 25, so it's 25 and
5/6.
And 5/6. All right, Serafina. Very, very thorough job with helping me to multiply my mixed numbers. And we see that when we finished up, our answer was we converted it back to a mixed number. So, Serafina, your name is going into our treasure chest because we treasure all of our callers who count on us. And we're going to ask Serafina and all of our callers to join us on the other side of the break. Stay tuned.
Can I do a challenge?
Yes. Join us on the other side of the break if you want to do the challenge.
Hello, my name is Jessica and I attend James Ryder Randall Elementary School. I am in the 5th grade. Today, the math problem is, during some months, Earth revolves around the sun in 30 days. How many seconds is this? Well, there's 24 hours in one day. So in order to find the hours in 30 days, I must multiply 30 times 24, which equals 720 hours. In order to find out how many minutes are in 720 hours, I have to multiply 720 times 60 because 60 minutes equal 1 hour. And that equals 43,200 minutes. Next, in order to find out how many seconds are in 43,200 minutes, I must multiply 43,200 times 60, because 60 seconds equal 1 minute, and that equals 2,592,000 seconds. So, 30 days equal 2,592,000 seconds. Woo! That was a lot of seconds. I hope you found the solution to your problem easy to follow. This is Jessica from Counting Us. Bye. See you next time.
Hey you, yeah you, stay right there, I gotta tell you something. I bet you know someone with type 2 diabetes. Guaranteed, you know why? Because 1 out of every 3 little kids is gonna develop diabetes in their lifetime. That is gonna lead to heart problems, strokes, and even blindness. I'm John Sally, and I'm telling you, it ain't gotta be that way. Now you can up your defenses by eating more fruits and vegetables, having more vegetarian and vegan meals. These steps can be the power plays to protect you and your family against the risk of diabetes. To learn more, go to blockdiabetes.org.
He was so inspiring.
He took chances.
He was so moving.
He lived daringly.
Martin Luther King Jr. was a man of service, and his day shall be a day of service.
He inspired us in words, but he led us in deeds. To honor him, let's do the same. Go to mlkday.gov and find out how to volunteer on Martin Luther King Day and beyond. This message is brought to you by the Corporation for National and Community.
Okay, guys, ready? Here we go! Let's smile and brush our teeth twice a day, every day. Let's smile and floss our teeth once a day, every day. Let's keep that smile a happy place on your face with good nutrition and dental visits. Let's smile, let's smile, let's smile, let's smile!
Of the elementary version of Count on Us. We hope you've been tuning in. Our number is 301-772-0080, flashing at the bottom of your screen. Give us a call so we can help you with your math homework. Give us a call so you can do some of our challenges. And hopefully you watched our little public service announcements that were in between the break, and you saw that we'll repeat again. Monday, you know we have no school. It's Martin Luther King Day, where we're celebrating, even though today is his real birthday, but it's a day of service. And we hope that you are planning, maybe with your schoolmates, maybe with your family, to do something to show and honor the service of Dr. Martin Luther King. On that note, we have a caller on the line, and it's someone who's back.
All right. Welcome back. Celafina.
Hi.
Welcome back. Can I ask you to turn your television all the way down and listen to us through the phone, please?
Okay.
All right. And you would like to challenge yourself. Is that correct?
Yes.
Okay. Did you already jot down the challenges?
No.
Okay. So let's put them up. So Celafina and everyone can look at the challenges. This is our 24 challenge. Celafina, do you remember how the 24 challenge works?
Yes.
Okay, would you like to explain it to all of our listeners out there, how the 24 challenge work, and then tell us which one you've chosen to challenge yourself with?
Well, there's 4 numbers on the card.
Which one are you going to use?
I want to do C.
Okay, so there are 4 numbers on the card.
And you can either add, subtract, multiply, or divide the numbers to get 24.
Okay, so you did a fabulous job explaining that. Thank you so much. I appreciate it. So Serafina is going to use 8, 8, 4, and 7 so that she comes up with a total of 24.
I already have an answer.
I love it, love it, love it, because I think we might have another caller who's going to attempt to challenge himself as well. All right. So you 8, 8, 4, and 7. Were those the correct numbers, Celafina?
Yes.
Okay. Go ahead and tell us what you were thinking.
8 minus 4 is 3.
8 minus 4?
No, 8 minus 4 is 4.
Okay, 8 minus 4 equals 4. Okay.
And then 7.
So I've used my 8 and I've used my 4.
And then 7 minus 4 is 3.
7 minus 4 equals 3. So I've used my 7.
And 8 times 3 is 24.
8 times 3 equals 24. Serafina has met the challenge! Way to go! Love it! You did a fantastic job with that, multiplying mixed numbers, and you did a fantastic job with this 24 challenge. So I'm going to ask you to stay tuned to the end of the show to see if you are indeed a winner of a fabulous prize. And Serafina, I have one more challenge for you.
Okay.
I would like for you to challenge some of your friends who are at your school or in your neighborhood to call us here at Count on Us. So who would you like to challenge to call us here at Count on Us?
My friend Geraldine.
Geraldine, you have been challenged by Serafina. Are you going to meet the challenge by calling us here? The number is 301-772-0080. We will be looking and listening for you, Geraldine. Where are you? Okay, so stay tuned.
All right, our next caller on the line, Terrell challenged himself to come back and do one of our 24 challenges. He did decide which card he wanted to do, but he may have changed his mind. So, hey, Terrell, you're back. Welcome back to Count on Us.
Yes,
and which challenge did you solve?
I did D.
You did D, so you did challenge yourself and figured it out. The numbers include 1, 4, 6, and 6. Tell me what you did with those to reach 24.
So I did 1 plus 4.
1 plus 4 is?
That is 5.
1 plus 4 is 5, so we use those two numbers.
Then I did 5 times 6.
5 times 6 equals?
30.
30. So that's the 5 that we had left and one of our 6s. We have a 6 left.
And 30 minus 6 is 24, ma'am.
30 minus 6 is 24, sir. Congratulations.
Terrell, you met the challenge. You met the challenge. Fabulous job. Okay, so your name is going in for a second time into our treasure chest because we treasure all of our callers who call in. And we are going to see if you are indeed a winner at the end of the show.
My name was in the box.
I'm sorry?
This is the third time.
The third? Oh, that's right, because you told us that it is Martin Luther King holiday. Well, the holiday is Monday, but today is his actual birthday.
So, Terrell, you're in middle school. You should know something about probability. The more times your name is in, what does that mean?
Say that one more time.
As you learn about probability, your name is in more times than the other callers. That means you have more what? Opportunities or chances to win. So keep watching to see if you are the winner at the end of the show. Let's see if probability is in your favor.
All right. So, Terrell, thank you for your call. And one more time, what was your friend's name that you challenged to call in?
Jonathan Breedlove.
Jonathan. Okay, we're going to be listening for Jonathan's call. And would you like to give a shout out to your teacher?
Yes, I would like to thank Miss Sadalia and for her help, and I wish she comes back from the Philippines ready to teach us.
All right. That was so nice of you. All right, so stay tuned until the end of the show to see if you are indeed a winner. And let's put our challenges back up in case we have some callers that are just now joining us and did not get a chance to take a look at the challenge or know the challenge. The challenge is our word scramble, which is related to our mathematics vocabulary, because as we mentioned earlier, vocabulary is equally important in mathematics as it is in reading. So you're going to ask us a yes or no question to see if you can unscramble the word, or you can unscramble the word and let us know what part of mathematics it has to do with. And our second challenge is our Old Faithful.
So we have the 24 challenge here. You are challenged to use the 4 numbers, addition, subtraction, multiplication, or division, and make these numbers equal 24, as we just heard Terrell do using this card. But don't give up on card D if he did solve it and you still are working on it, because, as I said, I challenged myself to see how many solutions I could find. So far, every card except for one, I found at least 2, some 3, and actually there's a couple I found 4 different solutions for.
Oh.
So keep challenging yourself. Give us a call. We do have a caller on the line.
Okay, so jot those down. And we have a caller. Can you tell us your name, please? Caller, are you there?
Hello?
Hello. Can you tell us your name, please?
Natalia.
Natalia. Oh, that's a beautiful name. And Natalia, what school do you attend?
Ernest Jess Middle School.
Ernest Jess Middle School. And what grade are you?
7th grade.
All right. And you are calling us with a math problem related to which topic? What's the math problem that you would like for us to assist you with?
-8 equals 2x plus 4. I need to find the value of n.
2n plus 4 or 2x plus 4?
2x plus 4.
2x plus 4.
Plus 4.
Okay. So we are going to solve for x. Is that correct?
Yes.
Okay. Were you given any type of scenario that this was related to, or just this particular problem to solve for x?
You mean was I given? No.
Okay.
I just have to solve this problem.
Okay. Well, what do you know about solving for x?
Huh?
Do you have any idea how you can solve for x?
Yeah.
Okay. Well, what do you know about solving for x?
What I think you have to do is take the number 4 and you do its reciprocal, which is -4.
Oh, okay. All right. Well, let's back up just a little bit. So I'm trying to think 2 times some number plus 4 is equal to -4. I'm sorry, -8. Did I write the problem correctly?
Yeah.
Okay. So 2 times some number plus 4 is equal to -8. Now, you use the word reciprocal. Actually, when I do the reciprocal, I am thinking of what number times 4 will actually end up equaling 1. So it's not exactly the reciprocal, it's called the inverse or the opposite. So right now I'm adding 4. I'm going to do the opposite of adding 4, which is subtracting 4, or think of it as adding a negative.
And why are we taking this 4 away? Why are we subtracting the 4? Sir, I'm sorry, Natalia. Why do we want to take away that 4?
Hello, sorry about that. My other phone disconnected.
Okay.
What were you saying?
Why is it that we are taking away 4?
You said why is it that we're putting
why did you want to subtract 4 from each side of the equation?
Because it says plus 4, so maybe you need to subtract it.
Okay, well that is an idea, but since we're solving for x, we have to end up, so the problem says x is equal to something. Right now I have 2x plus 4 equals something, so I want to get the x, the term with x all by itself.
Exactly.
That's sometimes referred to as isolating the variable, getting the variable all by itself with everything else away from it. So that's why right now I was adding 4. So I need to get that 4 away from it. So I'm going to do that by subtracting 4. Okay? Does that help?
Okay.
All right, so let's go ahead and subtract. If I have 4 and I subtract 4, that's going to give me 0. If I have negative 8 and I subtract 4, or I can think about it as adding negative.
Keep, flip, change.
Oh, keep, flip, change. Okay, what do you mean by keep, flip, change?
You keep the negative 8 as it is.
Mm-hmm.
You change the negative sign into a plus. Bleh. You change the subtraction sign to a plus sign, and then change the negative 4 to a positive 4.
Okay, so I wrote this incorrectly for you to use keep, flip, change. So if I say, well, actually, keep, flip, change will not actually work with this particular problem, because I am going to, here I am adding negative 4, so I'm going to add negative 4 to this side as well. So I didn't put an addition sign, so that might have confused you. So if I have negative 8 plus negative 4, I don't need to keep, flip, change. I'm going to leave everything the same as it is. Okay?
Okay.
So I'm really, with this particular problem, I could think about it as adding negative 4 to both sides of the equation. All right? So negative 8 plus negative 4.
Negative 12.
Very good. Negative 12. So I had negative 8, and I got 4 more negatives, so that gives me a total of 12 negatives. Now, this side is the positive 4 and the negative 4 equals 0. So now I have 2x is equal to negative 12. I didn't want to find out what 2x was equal to. I wanted to find out what x was equal to. So what do you think we should do now?
Divide each side by 2.
Why 2?
Because it says 2x, so you have to divide it by 2 so that it cross cancels.
Okay, we're going to divide both sides of my equation by 2. And notice that each time I'm putting an equal sign here, and I'm doing the same thing to both sides of my equal sign, at all times the equation must be balanced. So if I divide by 2 on one side of the equation, I have to divide by 2 on the other side of the equation. We have to be fair when we're solving equations, okay?
Okay.
All right, so let's see what happens when we divide both sides of the equation by 2. 2x divided by 2 will give me how many x's?
1.
Okay, because 2 divided by 2 is 1. So that same 1 that Miss Sternberg was talking about when she was working with her fraction problem is the same one that I have here. Now, what about negative 12 divided by 2? What does that give me?
Negative 6.
Negative 6. Okay, so we're saying if I substitute a negative 6 in the place of my x in my original equation, it will give me a true statement. So when you're solving equations, we always want to go through and make sure that we indeed end up with a true solution. So I'm going to go back and put negative 8 is equal to 2 times, and here I'm going to put negative 6. Plus 4. Okay. These markers are getting to my eyes. Okay, so let's go here. What's 2 times negative 6?
Negative 12.
Negative 12 plus 4. What's negative 12 plus 4?
Negative 8.
Negative 8. And so we see that, I'm running out of space. We see that negative 8 is equal to negative 8. Negative 8 is equal to negative 8. So we see that negative 6 is indeed our valid solution for this problem. We have indeed solved for x. Does that help?
Yes, a lot.
Oh, thank you so much for your call. And your name is going into our treasure chest. Now, I have a question. Were you a first-time caller?
Yes.
All right.
Congratulations. Thanks for calling, Count on Us.
Thank you so much for calling.
Thanks for the people who are on the line. We're going to try and get another call in. We have Celafina back. Hi, Celafina.
Hi.
And what's your problem this time?
I needed some more help on my homework.
All right.
Okay.
So we'll help you with your next problem. Tell us what the problem is.
It's 2/9
2/9
times 6/8.
times 6/8. And we've done a couple of problems like this already today. So now if we look at this problem, there's two ways to solve this problem. How did your teacher tell you to solve it? What does your teacher want you to do?
Well, she said if you can find a common factor,
Yes.
or you multiply it.
Okay, so if we can find a common factor, we can simplify these numbers here, and then we're not multiplying such big numbers. So do you see any numbers that might have common factors? What numbers do you see?
8.
8 and what?
8 and 2.
The 8 and the 2. Excellent. And what's their common factor?
2.
2. So we're going to divide 2 by 2. How much is 2 divided by 2?
1.
1. Any number divided by itself. So that makes that a 1. And how much is 8 divided by 2?
4.
4. So now this becomes a 4. So now it's a smaller number for when we multiply. Anything else you want to do, or you want to just do our multiplying?
And you can do 9 and 6.
You can do 9 and 6. So what's a common factor of 9 and 6?
3.
3. So 6 divided by 3 is?
2.
2. And 9 divided by 3 is?
3.
Excellent. Now, instead of having to multiply 2 and 6 and 9 and 8, we're multiplying 1 and 3 and 2 and 4. Excellent. So now we have a simpler problem. How much is 1 times 2?
Write it down.
How much is 1 times 2?
2.
2. And how much is 3 times 4?
12.
12. Now, is this in simplest form?
No.
No, because once we see that they're both even numbers, we know we can divide them both by?
2.
2. 2 over 2, which is really 1, but we're making it into an equivalent fraction. How much is 2 divided by 2?
1.
1. And how much is 12 divided by 2?
6.
Excellent. So 2/9 times 6/8 is 1/6. You know your multiplication facts, and that is such a key to helping you solve fractions, because it's hard to do fractions without knowing multiplication. Excellent job. And that was Celefina back on the line, so she's getting another opportunity to
Yes, she is.
She's in there right with you.
From
Glenarden Woods.
And you know what? I think she challenged one of her friends.
Who did you challenge, Celefina?
Geraldine.
Oh, so we are looking and listening for Geraldine.
And
all right.
All right, wrapping it up. Let's see who our next caller is and see if we can get that person on the line.
Caller, are you there?
Who's on the line?
Hello?
Hi, who's this?
This is Geraldine.
Geraldine!
Well,
Geraldine, do you know anyone who may have called earlier?
Yes, Celefina.
Oh, so Celefina and Geraldine's, both of their names are going into our treasure
We're
chest.
running out of time, so I'll write the names. You take the problem real quick, see if we can help them. And
okay, let me write the name and you take the problem so I don't have to write backwards.
All right, let me take the problem. So here we go. What is the problem, Geraldine? Geraldine, what's your problem?
My problem is 3 1/3.
3 1/3
times 2 1/2.
2 1/2. And this is a very similar problem to what Celefina did. So you're working on multiplying mixed numbers. And when we have a mixed number, what's the first step? We have to change these to what?
You have to change them into an improper fraction.
Exactly. First thing I like to do is say, well, the whole number's 3 and 2. So we know we're going to have a number. What's 3 times 2?
What?
How much is 3 times 2?
3 times 2?
Is 6. So we know our answer is going to be bigger than 6. But let's quickly, we're going to be out of time, so I'm going to do a part of this with you so you can watch. 3 times 3 is 9, plus 1 more is 10. 10 over 3, or 10/3, because we keep our denominator. 2 times 2.
2 1/2 will equal 5 over 2.
Exactly. I'll put that next to it. 5 halves, 5 over 2. And now we're going to multiply. We could do a simplification here, but let's do the quick multiplication. So we want to multiply. How much is 10 times 5?
10 times 5 equals 50.
Is 50. And 3 times 2 equals? 3 times 2 is 6. And now we have 50 divided by 6. And 50 divided by 6, because we got to put it back into a mixed number. How many 6 are there in 50?
8.
8. 8 times 6 is 48. So we're going to have 8 and 2 6. And 2 6 simplifies to be 8 and 1/3.
Wow. That was a mouthful. Okay, so if you have any additional questions, you can join us on the secondary show that's coming up in just a few minutes. But we really appreciate all of our callers. Names have gone here multiple times. The probability is...
Yep, the probability was there.
The probability was on your side.
Excellent.
And we want you to know that each Monday and Wednesday, the elementary show airs from 4 to 5 p.m. And the secondary show airs immediately following from 5 to 6 p.m. And remember, you can always count on us.
Welcome to your mini lesson today. My name is Mrs. Jacks, and today we will discuss how to change mixed numbers into improper fractions, and the reverse of that, how to change improper fractions into mixed numbers or whole numbers. Let's go ahead and look at an example. In this example here, once again, it says changing mixed numbers to improper fractions. We have a mixed number here. A mixed number is when you have a whole number paired with a fraction. This one happens to be 3 1/8. We're going to go ahead and change that into an improper fraction. The first step is to multiply the whole number by the denominator. So 3 times 8 is 24. After you do that, well, let me go ahead and show you. 3 times 8 equals 24. You have the numerator here. We're going to go ahead and now add the numerator to our product. 24 plus 1 equals 25. This final answer becomes your new numerator, and the denominator stays the same. So 3 1/8 changed to an improper fraction happens to be 25 over 8. An improper fraction means that the number on top, which is the numerator, is greater than or larger than the number on the bottom, which is the denominator. We can also reverse this. We can change improper fractions back to mixed numbers, and I'm going to show you how to do that now with this second example. Changing improper fractions to mixed numbers or whole numbers. This first one here is an improper fraction. Once again, that means that the numerator is larger than the denominator. The first step is to divide the numerator by the denominator. Okay, so I'm going to set this up as 56 divided by 7. If you already know the answer, you can of course put the answer here, or you can set it up the long way using an algorithm. 7 goes into 56 8 whole times. 8 times 7 is 56. And then with the algorithm, you will go ahead and subtract, and your answer is 0 here, so you don't have anything left over. There's nothing else to continue dividing by. So your answer happens to be 8. So in this case, you can change an improper fraction to a whole number. Let's look over here. This one is a little different. This is 55 divided by 7. So it's one number less than 56. Let's see what happens when we do that. 55 divided by 7, we will do it the same way. 7 goes into 55. It doesn't go exactly 8 whole times. It's going to go in 6 times, and then we're going to have something left over. So let's go ahead and set up the algorithm. 55 divided by 7. Well, I'm sorry, I said 6 times, excuse me. It goes in 7 whole times. So 7 into 55 is 7. 7 times 7 is 49. To complete the algorithm, you need to go ahead and subtract. 55 minus 49 gives you 6. So 6 is your remainder. Now, to set up our answer, the whole number here becomes our whole number for the mixed number. And then the remainder becomes the new numerator. And guess what? The denominator stays the same. So 55 sevenths, which is an improper fraction, now becomes 7 and 6 sevenths as a mixed number. Once again, this was a short mini lesson on changing improper fractions to mixed numbers and changing mixed numbers to improper fractions. Thank you for your time.
Minds can achieve anything. We make sure they get to college. Federal student aid provides more than $150 billion in grants, loans, and work-study funds to make college possible for anyone with the mind to get there. Because if given the chance, minds will do great things. Federal Student Aid, proud sponsor of the American Mind. Learn more about money for college at studentaid.gov.
Because how many ways are there to solve math?
Many! Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel? All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solve perimeter is
2 times length plus 2 times width.
Good afternoon. Hi. Fancy seeing you guys again. Welcome to your secondary edition of your Telly Award-winning math homework hotline. I am Mrs. Davis here, this time with my fabulous partner.
Oh, I'm so happy to be next to Mrs. Davis. My name is Ted Herman. We're here to answer all your questions on Count on Us, the intermediate high-level question part of the show from 5 to 6 at 301 772-0080. Also on the World Wide Web, you can go www.pgcps.org.
As in Prince George's County Public Schools. And we have a couple callers that have been so patiently waiting on the line. We really appreciate them. We are going to review our challenges. Mr. Herman, you're looking quite swell.
I'm trying to become dapper. I'm working on being dapper.
I don't know if you can be any more dapper than you already are. Okay, so let's just review our challenges because we have a couple callers who are waiting to do it. We'll continue with these so that they can challenge themselves.
Okay.
And the way that the 24 challenge works, Mr. Herman?
is you take all four numbers. You must use all four numbers in the circle, people. And make sure you add them or subtract them or divide them or multiply. Multiply is the fourth thing we can do.
Add, subtract, multiply, or divide.
Yes, I already said that. Anyway, I'm being dapper here. So take all four numbers, multiply, add, subtract, divide, and make 24 happen for your answer. So what we suggest all our callers to do is copy letter A, and that's this one right here, 2127, Miss Davis.
Card B, this is shaded in, so it is a 9887. Card
Nice.
C.
You read numbers very well, Miss Davis.
Thank you.
And then part C is 8478.
And card D, and from the previous show, we had a solution for 4166.
That's the hardest one on the plate because it has 3 dots right there. Making a super. Hey, any more challenges, Miss Davis?
Well, we do have the word challenge that's right underneath. Let me have it, please.
Oh, I don't want that to you.
Okay, so here we go. Again, the math vocabulary is very important, so unscramble this word for a math vocabulary word. You may ask me a yes or no question prior to unscrambling as a clue, and then you're off to the races.
I'm sorry, I already have the solution for this one. It's Jack Nicholson.
Wrong.
Well, I tried, didn't I?
You did. I'm going to give you an E for trying.
It's important.
E for effort. All right. E for effort. That's a good thing. I appreciate your effort.
This is a very long show today.
All right, here we go. We have Natalia. Oh, no, I'm sorry, not Natalia.
No.
We have a caller.
Rose. I think.
Please stay on the line. We will get to you momentarily. And caller, are you there?
Yes.
Hi, welcome to Count on Us. Can you tell us your name and the school that you attend?
Rose at CT Reed Elementary School.
All right.
I know
Now,
Rose.
I have not had the pleasure of meeting you before.
I met Rose before. She's great.
Rose, I have a question for you. Are you a frequent fan of Count on Us, or is this your first time calling?
This is my third time.
A frequent fan, Mr. Ted.
She's called me a lot. I love Rose.
A frequent fan. Okay.
Rose.
And Rose, I have one more question before we get to yours. Have you challenged any of your friends at school or in the neighborhood to call Count on Us as well? Who would you like to challenge to call us today?
Nobody.
Nobody? Does that mean you have no friends who are working on their math homework at all?
No.
Oh, so you
Rose
must
is
be
so special.
a
She's
single
trying to keep
student,
it all to
herself. But we're here for everyone across this Prince George's County School District. Okay, Rose, we're ready for your question. Rose, what are you working with?
6 divided by 3/4.
6 divided by 3/4.
Want me
Mr.
to write
Herman?
that for you? I'll write it for you, Miss Davis.
All right.
And you're going to work it through with Miss Rose?
6. And what grade are you, Rose?
5th.
5th grade.
How about like that? Is that the way it looks in your homework or whatever?
Yeah.
Okay.
Great. Can we go ahead and put a number right below the 6 to make it a fraction without changing the value of the 6?
Put a 1 as the denominator.
Oh my gosh, she used good language. Didn't she use good vocabulary, Miss Davis? A 1 in the where? Did you say denominator?
Uh-huh.
I'm so proud of you. Now, as we know, with division of fractions, we have a hard time doing it straight up like that. But we can do a really cool thing. Change the division sign to what?
A multiplying sign.
A multiplying sign. So we're going to go like that. And then if we do reverse of that, which is now division to multiplication, we do 3/4 and do a flip and make it into what?
4/3.
And you are so good, Rose. I'm going to ask you a tough question. What's that called when you do a flip from here to there and from there to there? It's a
It's a It's a left.
Well, that's easy for you to say, but I think I'll have to help you out with that one. Can you say reciprocal?
Reciprocal, yeah, our teacher told us that today.
Oh, that's great. That's wonderful. We're reinforcing it right here for you. So go ahead, Rose. Give it your best multiplication. What's 6 times 4?
24.
I love your style, Rose. You're a great caller. And 1 times 3?
3.
And is that the way we want to leave our answer, like that, 24 thirds, or change it?
And we change it, it equals 8.
Oh my goodness, 24 divided by 3. She knows her facts. I got to give you the rattlesnake.
Oh.
And she gets her name. Rose gets her name.
I will be putting it right into our treasure chest because we treasure all of our callers.
You want to try a challenge today, Rose?
Yeah.
Which challenge you want to try, sweetie?
Challenge of the day.
The word of the
day? I bet you have something. Okay, can I give you one hint? It has something to do with math. Okay?
No, the other one.
The 24 challenge?
Oh, wait a minute. This one?
No, Mr. Herman.
Well, it's a challenge.
She is
Just
talking
calm
about the
down.
24 challenge.
I got you. 24 challenge.
Okay.
Which letter? A,
D.
B, C, D.
D.
B as in boy?
D as in dog.
D as in dog. My hearing's going bad.
Okay, so the numbers are 4, 1, 6, 6.
And here we go. Here we go.
We will do our best to assist you. 4, 1, 6, 6. I'm writing backwards today. All right, so what did you have in mind?
4 times 1. Wait, yeah. No. 6 times.
Don't play with my emotions, Rose.
No. Wait, 4 times 1, yeah.
4 times 1. Okay, once you use it, that's what we're going to go with. 4 and 1 have now been used. And what is 4 times 1?
4.
Mm-hmm. Now you got to use the 6 and the other 6.
6 times 6.
Huh. What's 6 times 6?
36.
Now what are you going to do with the 36 and the 4? Used up all these numbers.
Now we subtract it.
Oh, okay. So what are you going to subtract? 36 minus what?
Uh-huh. It's 32.
Oh, so we didn't quite meet the challenge because we were trying to get 24. I want you to persevere with this and see if you can come up with a solution, okay?
Good try, Rose.
So you can give us a call back if you get a solution, all right?
All right.
And we do have several callers that have been waiting patiently. Thank you so much for waiting so patiently. And is this caller? Are you there?
Hello?
Hi, caller. Are you there?
Hello?
Hello. Welcome to Count on Us.
Hey, it's me, Natalia. I want to do a challenge.
Hi, Natalia. I thought you might be calling to do a challenge. Which challenge would you like to do?
24 challenge, letter A.
Letter A as in apple, and we have not had a solution for that yet. Okay, so the numbers are 1, 2, 2, 7. 1, 2, 2, 7. Okay, did you come up with a solution?
Yes.
Okay, what did you do?
7 times 2 equals 14.
7 times 2 equals 14.
14 times 2 equals 24.
14 times 2 equals how much?
24.
Okay, let's double check. Let's double check by adding.
Wait, no, man. That was 28. I thought that was 24.
Okay, so let's add it up, and it is?
Get a grip, Natalia.
So close. Okay, so we use the 2. You want to give us a call back? You were so close. All right, thank you so much.
No, I got it now.
Okay, what you got? What you got?
I got it too. I got a headache.
What you got?
2 plus 1 equals 3.
Okay, let's do that.
Wow.
So erase.
Oh, I'd erase that.
Okay, so erase and start from the beginning. 2 plus 1. So we've used the 2 and the 1. Okay.
And wait, hold on. Just give me a call back.
All right. Well, we're going to be right, Natalia. We're going to be right here waiting for you until 5:55. You can give us a call back when you have worked out that challenge. Persevere with mathematics, which is what we expect all of our students across the county to do.
We're here for you, Natalia. We're here to help you.
All right. And we do have another caller. Caller, are you there?
Hello?
Hi. Welcome to Count on Us.
Geraldine.
Hi, Geraldine.
I have another problem.
You have another problem, and we are right here to help you with that other problem.
We all have some problems in our lives, but we got to work them through, Geraldine. Just get it through. We're going to work this. This is my caller now. Okay. Let's go, Geraldine. Let's go, girl. Give me your problem.
My problem is, it's like, it says, what is AB if A equals 1 and 5/11 and B equals 7/8.
Okay.
Okay.
Can you repeat that? Repeat the problem for us.
5/11 times 7/8.
Okay, so A equals what again?
1 and 5/11 times 7/8.
And B was 7/8. And you were saying AB, very good like that, which means multiplication. When you have a letter, a variable next to a variable, it's just automatic multiplication, right, Geraldine?
Yep.
So now we're going to take 1 and 5/11 in place of the A, and the B becomes times 7/8. Hey, you know what? What's this 1 and 5/11 called, Geraldine, when we have a whole number to fraction? What?
A mixed number?
Yes.
Very good.
And do you know how to change a mixed number into an improper fraction so we can multiply?
11 times 1 equals 11.
Excellent.
Plus 5 is 16 over 11.
So you get 15/11. You are on the ball. You're saving my whole show. I love it, Geraldine. Now,
15 over 11.
what's that? 15 over 11, right? 15/11 times 7/8. Do you know 15 times 7?
No, because 11 times 1 equals 11 plus 5 equals 16, not 15.
You know what? You're absolutely right. Way to catch that. I want to see if you're paying attention. Nice job. That's great. So 11 times 1 callers is 11 times 1 is 11, plus the 5 is 16. Wow. So what's 16 times 7? Let's do that real fast.
No, you can do simplify before you multiply.
Do you know how to do cross cancellation? Wow, you're learning a lot. What school are you at? Glenarden Woods?
8.
Whoa, okay, 8 divides into itself how many times? 1. And how many times did 8 go into 16?
2.
Yeah, you just made our work a lot easier. So what's 2 times 7, Geraldine?
14.
And what happens to 11 times the 1?
11.
And we can't leave it improper like that, because that's very improper. It's like nasty. It's wrong. So make the 14/11 into a mixed fraction. How do you do that?
11 can go into 14 one whole time, so 1 is your whole number.
Uh-huh.
And 3 is left over, so that would be your numerator, and your denominator is 11.
That stays the same. Can you say the whole mixed fraction for the answer?
What?
Can you say the answer with the mixed fraction sound?
Yes.
How do you say it?
Wait.
1 and
very well.
1.
1 and 3/11.
Oh my goodness!
Very good, Geraldine.
Stop it! The
Your
bell.
name is ringing into the treasure chest because we treasure
what a great
all of our callers.
Hey, you want to try a challenge, Geraldine?
Well, we have several callers that are waiting.
but
So
she's been waiting a long time.
Geraldine called
what's
us
your challenge?
on the second
Don't grab my arm like that again. Hello, security. We're in room 201. Please come to the third floor. Thank you. It's good to see you, Miss Dave. Well,
good to see you,
since you
too.
got so physical, my arm feels. Can Geraldine call back or something?
Yes,
Okay.
Geraldine, we're going to ask you to call back to do a challenge for us, okay? So go ahead and write it down.
Wait.
Wait.
Okay, go ahead and write down the challenges.
Oh, write down the challenges.
Uh-huh.
I already know one.
Okay,
You already know one.
Geraldine, we have a couple other callers, so we're going to ask you to call back if that's okay. We have like 4 other callers who are waiting who haven't had a chance to get any help, okay?
Oh, we'll save a spot for you, Geraldine, I promise.
All right, and we have another caller. Caller, are you there?
Yes.
Okay, can you tell us your name and the school you attend?
TT Glenarm Woods.
TT! I have a question for you, TT.
Yes.
Is this your first time calling, or are you a frequent fan?
She calls a lot.
Frequent fan.
Yay!
Just keep your space, please.
Okay.
Keep your space.
All right.
Thank you.
Okay, we are now drawing the line, Mr. Herman. Okay. You stay there, and I'll stay here. All right.
Fine. I'll be on my side, and you stay on your side.
All right. Well, then you can help TT.
I can help TT?
Yes, you may help TT.
No, I'd be happy if you'd help TT. I definitely want to get Zoe, because that's my student later on.
Okay. All right. TT.
Yes.
How may I help you today?
With multiplication.
Multiplication. All right. What exactly are you multiplying, TT?
Yeah, what are you multiplying?
191.
191.
Times 10.
Times 10. Okay. Is that what you're multiplying? 191 times 10?
The other way with the 191 on top and the 10 on the bottom.
Okay. All right. If you would like it that way, 191 times 10. Okay, do you know anything about any shortcuts for multiplying by 10?
Yes.
Oh, well, what shortcut do you know?
10, 20, 30, 40,
50.
Keep on adding 10.
And you keep on counting by tens. So we would have to count by tens how many times?
3.
191 times. So that's not, we could do that, but that's not the most efficient way to do it. So let's use our multiplication procedure. So this means I'm going to have 10 groups of 191. So 0 times any number is?
0.
0. So I don't even have to make a whole row of zeros. I'm just going to mark my ones place with 0. And what is 1 times any number in the whole wide world?
1. Number.
The number. So if I say, think of 1 times 191, what was 1 times 191?
191.
191. So here, when I multiplied 10 times 191, I have 191 with a 0 in the ones place because there's a 0 in the ones place for the 10. Okay? So can you say this number for me?
1,910.
Okay.
Oh, I heard an.
1,910. We only say and at our decimal point, okay?
Okay.
Did that help you out?
Yes.
Okay, so I could have done the problem this particular way because I know I'm going to have 191 because 1 times 191 is 191 and I have a 0 in the ones place, so I could put a 0. And look, either method, horizontally or vertically, we came up with this exact same product. And so, TT, your name has gone ta-ta into our treasure chest.
It's going where?
Into the treasure chest, Mr. Ted. Into the treasure chest, my dear. All right, and please stay tuned to the end of the show to see if you are indeed one of our fabulous prize winners. And we do have another caller who has not called for this show.
But she's called before, Celafina.
Okay, look.
And you can have Celafina too. I definitely want to get Zoe.
Hello, Celafina. How are you?
I'm good.
Okay, and you're still working with mixed numbers?
Yes.
Okay,
that was my homework.
You know what? You are taking advantage of your resources. So if you need help with homework, and this goes for any student throughout Prince George's County, you can call us each Monday and Wednesday here at your Telly Award-winning homework hotline. The number is 301 772-0080. And we are
since it
here
is
to help you.
Since it is a Telly award-winning show, you can use your telephone
to reach out and touch us, right, Mr. Herman? Yes. Okay. All right, Salafina. If you would give me your problem while Mr. Herman stews on that a bit.
My problem is 6/7
6/7
times 10 seconds.
10 seconds.
10 seconds.
Okay, so are you saying 10 is in the denominator?
Yeah, I mean, yeah.
Okay, so even though my writing is not of the neatest caliber today, instead of calling this 10 seconds, we actually call it anytime
10
halves. So
Beautiful.
6/7 times 10 halves.
Beautiful.
Now, there is a shortcut way that we can simplify our numbers so that we have much smaller numbers to work with. Celafina, are you familiar with that strategy?
Yes.
Okay. Should we try that for this particular problem?
Yes.
All right. I'd love to work that with you. Okay, so what are we going to do if we're using that particular strategy? 6/7 times...
Well, there's two ways. You could either divide 2 and 10 or 2 and 6.
I really like the way you're thinking of multiple entry points for this particular problem. Now, which strategy would you prefer to use today?
I want to do 2 and 10.
2 and 10. You want to simplify 10 seconds?
Yes.
Okay. And instead of seconds, what did I say we're going to call it instead of
10
seconds?
halves.
10 halves. So how could I simplify 10 halves?
Well, 2 goes into 2 ones, so you would change the 2 to 1.
Okay, so 2 is our common factor. It is the same thing as dividing by 1. So 2 divided by 2 equals 1, and 10 divided by 2 equals?
5.
5. Very good.
Cool.
So now, instead of having to multiply 10 halves times 6/7, I am going to multiply 5 times 6/7. Okay?
So your product would be 37.
Okay, so now I'm going to multiply 5 times 6, which is 30.
Good job, Celafina.
And 1 times 7, which is 7. Now, and we want to have it in what's considered simplified form. Sometimes we call this as a fraction greater than 1. Or Mr. Herman likes to call it, Mr. Ted likes to call it improper. So either name is sufficient. So a fraction greater than 1 or an improper fraction. So we're going to do what to simplify this fraction greater than 1 or improper fraction?
You have to divide the denominator to the numerator.
Love that math vocabulary. 7 divides into 30. How many times?
4, which is 28.
Which gives me 28. I'm going to subtract. And how much do I have left over?
2.
2. And what do I do with the 2 that's left over?
Well, that would be your remainder.
That is my remainder. And when I'm working with fractions or mixed numbers, what do I do with a remainder?
Well, first the whole number would be the whole number in your new mixed number.
Okay.
And then your remainder would be your numerator.
Okay.
And your denominator would stay the same.
I love it! Serafina! Maybe you could one day join us here and help some other students with math problems.
I would love to.
Oh, well, you'll have to get your parents' permission and your teacher's recommendation, okay?
Okay.
Thank you so much for joining us today. And your name has gone in another time.
Excellent job, Celafina. And all of our callers, please stay tuned. We're going to go to a short commercial break, hoping you're going to come back to us to get some more interesting answers.
So join us on the other side of the break.
I'm Cameron from Samuel Ogle Middle School, and today's email question is from Ted at Rockledge Elementary. Ted wants to know the area and perimeter of a rectangle that measures 3 inches by 6 inches. Well, let's start with the perimeter. The perimeter is round. So we add all the sides. Okay, so we know that if 3 inches is on this side, then 3 inches is on this side. And if 6 inches is on this side, 6 inches is on this side, because the opposite sides are equal. Now we add 6 plus 6. 6 plus 6 equals 12 inches. And 3 plus 3 equals 6 inches. Now 12 plus 6 equals 18 inches, which is the perimeter. Now we do the area. The area is the inside. So we can either count the squares, or we can do length times width. And the length would be 6 inches, and the width would be 3 inches. So let's do both. First, we'll count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now we know that we have 18 inches squared, since we used the squares. And the same thing goes for length times width. So now we do 6 times 3. 6 times 3 equals 18 inches squared. And this is the area. Well, Ted, I hope that was helpful to you. So that's Cameron, and see you next time.
Wait a minute. That's wrong. All people are people.
Take the time to get to know people, and you'll see that all of these labels are false. Don't let prejudice shape your view. Stereotyping is wrong, and it hurts all of us.
Stop stereotyping.
A message from your American Muslim neighbors.
When I was a kid, I dreamed of being a stuntman.
I went from dream to dream pretty quickly. I wanted to be a cowboy. Tom Cruise in Top Gun.
I dreamt of being a nun.
Actually, before that, it was Popeye.
Malaria kills more than 2,000 children a day.
Text NET, N-E-T, to 85944 to make a $10 donation to Malaria No More.
Oh, messaging and data rates may apply.
Let's make malaria no more.
And thank you for joining us for the second half of your Telly Award-winning Math Homework Hotline. I'm Mrs. Davis here with my fabulous co-host.
Friends, are you feeling tired, run down, a little sluggish? Then call our show and you'll get pumped up with all the math answers you want to know. What?
Okay, so you can get pumped up with Count on Us. Yahoo! Get it pumped, get it pumped.
Oh my
all right.
goodness. And all
so
I
the number is, you want to say the number?
The the first half of the show, they had a great close-up of Miss Davis. I haven't gotten my close-up yet. So I'm a little bit sad by the way I've been handled today.
All right, it's just fine. They're going to handle you correctly.
I hope so.
All right, so the number again is 301-772-0080. We're here to help you with any math homework that you might be having.
Oh, my goodness. And I hope we have a caller out there named Zoe.
Zoe, are you there? Is that Zoe?
I can't see.
Yes.
Hi,
there
Zoe.
she
We
is.
have been waiting for you.
She's behind the table.
Okay.
Hey, Zoe. Who's your math teacher at your school?
Zoe?
The one to the right.
The one to the right.
Mr. Herman.
Mr. Herman!
Hey, Zoe. Watch this, Zoe. Oh, yeah. Uh-huh. You got it, girl. Because you're one of my favorite people in the class. And Zoe, for anybody who doesn't know Zoe real well, she is taking care of a wild penguin of her own. How is the penguin doing? What's the penguin's name again?
It's good.
Is Tiffany?
Tiffany.
Tiffany. And
Wait a
Tiffany
minute.
lives in your house.
Wait a minute. Where did you get a penguin, Zoe? If I may pry into your personal penguin.
Pretty amazing.
Personal penguin affairs.
What did you say?
Where did you get a penguin, Zoe?
I found the penguin on the floor in my room.
Oh, what a pleasant surprise. All right, so because we have several callers waiting for math homework help, we'll find out more details about the penguin a little bit later on in the show, if that's okay.
That's great. I hope you feel better, Miss Davis. Mrs. Zoe, what's your problem today?
Mr. Herman.
Okay.
I'm the problem. Yes. What's your problem today on the show, Zoe?
Zoe, what are you working with? How can we help you? Zoe, can we ask you to turn your volume all the way down or mute your television because we're hearing the echo, so that might be the problem.
I hear a dial tone now.
Zoe?
Somebody's calling.
Hello, Zoe. Is your problem 16 times 5?
If you'd like to make a call, please hang up and try again. If you need help, hang up and then...
Hello? Sorry.
It's Zoe, and her problem is 16 times 5.
Okay, 16 times 5, which is amazing to me because we're learning about geometry for the last 2 weeks. So why she's doing that, I have no idea.
For review, of course. Math never gets old, Mr. Herman.
Oh, I'm getting old, but math doesn't.
Math
5 times 6 is what? Zoe's back. Zoe, what's 5 times 6, sweetheart?
Hello?
Remember, I know where you learn. So give me an answer, please. 30. 5 times 1.
5.
Plus the 3, Zoe.
8.
Yeah, so how do you say the answer, Zoe?
80.
Nice. And since we're learning about geometry, we're going to call it 80 triangles, okay? 80 triangles. So Zoe gets her name into the treasure chest for being so sharp on multiplying things we learned 3 months ago.
And you always want to review.
Thank you.
Math never gets old, Mr. Herman.
Mr. Herman, are you happy now that I called in?
Look at that happy face. He couldn't have a happier face if he tried.
I'm happy.
And I'm happy too.
You'll be happy tomorrow when I see you in class.
Yes.
I can't wait. Yes.
Zoe
Thank you,
from
Zoe.
Mount Airy?
Mount Rainier.
I'm sorry.
Mount Airy is way far away. We'll say Mount Rainier's a little closer.
Rainier. Zoe from Mount Rainier. Zoe, your name is going into the treasure chest because we treasure all of our callers.
And tomorrow I'll put Zoe in the treasure chest, her whole body, I think.
Oh, no, Mr. Herman. We won't have any of that.
No.
None of that.
Oh, sorry.
Nix A on the treasure chest A. Only this treasure chest. All right, we have another caller who has been waiting very, very patiently. Caller, can you give us your name and the school you go to?
Hello. My name's Rashawn.
Your name is, again, please?
Rashawn.
Rashawn.
Rashawn. Welcome, Rashawn.
Oh, don't you go to Greenbelt Middle School?
Yes, I go to Greenbelt Middle School.
Yeah, and you're a guy, right? You're a boy or man?
Can you repeat that, please?
Okay,
Doesn't matter.
Mr. Herman. Mr. Ted, enough of your shenanigans. What are you working with, Rashawn?
Right now, I'm requesting help for special right triangles.
Special right triangles. All right.
That sounds
Can I
special.
ask what grade you're in?
Right now, I'm in 8th grade.
All right.
Well, hopefully it'll be 9th grade one day.
All right. Next year, because he's going to get some help with this right triangle, a special right triangle.
Can I ask Rashawn one question, Miss Davis?
You may ask him a question.
Is it a 30, 60, 90 special right triangle or a 45, 45, 90?
It's 45, 45, 90.
Ooh.
Okay,
so
I
this
didn't
is
quite draw it correctly.
not quite perfect. But
Okay, go ahead.
Nothing's perfect in math, as long as you get close to it.
Okay, so we're going to freehand, which means we're not using our protractor to measure to get the exact angles, but we're going to make a diagram to symbolize the information. So even though if it is not drawn to scale, we are going to use our diagram to give us clues as to what's going on with the triangle. Okay.
Can I ask Rashawn one thing? What does this symbol mean right here when you have the arc of the angle and a little slash like that?
Can you repeat that?
What are these angles if they have the same kind of symbol notation?
Do the angles have some sort of... What do those mean?
Yeah, what does that mean when you have the same exact little...
they're equal.
They're what?
They mean that they're equal.
Right, or congruent, right?
Mhm.
So that's
Yes.
45, 45, and the 90, of course, goes right here. So what are you trying to find out? Do you have any other dimensions at all?
Well, side A
Mm-hmm.
is X. Has a length of X.
Is that right here? Or down
What?
there? Where's the X? Where's the side A?
X is a variable.
I know. Can you see the screen? Is
I
it one
do.
of the legs or was it the hypotenuse?
It's one of the legs.
Okay, so we're just going to call this side AX. And what about this one?
Okay, and the second leg is also X.
Right, because they're both part of the congruency. If your angles are congruent, then your complementary, your corresponding sides are congruent. Very good word, corresponding.
Mhm.
Now, what about this hypotenuse?
The hypotenuse is 12.
12. And what are you trying to find?
And you're trying to find the value of X in simplest radical form.
Wow.
All right.
Well, all I can tell you about with a special right triangle, and Miss Davis can get in on this too if she wants, is that when you have one of the legs, one of the sides or the legs, if you take that and multiply it by the square root of 2, that'll give you the hypotenuse. Okay? But what Miss Davis is doing is really cool too. She's doing a thing called Pythagorean theorem. Have you ever seen that, Rasan?
Yes, I have.
Great. So let's just clean up these letters a little bit. And we can plug in a squared with an x squared. Is that what you want to do?
Mm-hmm.
Okay, x squared again, because they're both the same length, x. And that's going to be 12 squares. See how we did that, Rashawn?
Yes.
Okay, we plug the 12 in place of the hypotenuse C. Now, x squared plus another x squared makes how many x squares altogether?
Would that be 2x squared?
Oh my goodness, you're great. And that's she's showing a 1 in front of each one. And do you know what 12 squared makes, Rashawn?
The 12 squared is 144.
Outstanding. And now we want to simplify this left-hand side. What can we get rid of first?
You could divide both sides by 2.
Outstanding. This is great. This is going really well. I like that Pythagorean theorem you did there, Mr. Davis. They really got things going right. What's 144 divided by 2, Rashawn?
144 divided by 2 would be 72.
72. And then, how do you get rid of the square with the x squared side?
So then you'd have to find the square root of both sides.
Right, you square root that because the opposite of square is square root, and you got to do the same thing to that side. And what happens to the square root and the square?
They cancel each other out.
Beautiful word. Cancel each other out. You're left with x equals square root of 72. And you want to put this in simplest form, you said?
Yes, in simplest radical form.
Simplest radical form. So you're not going to get a calculator and try to square root 72.
Right. So we're going to break it up into two numbers that multiply to give us 72.
And what would those two numbers be? One of them should be a perfect square.
Yes.
Two numbers. I think one of them could be 9
and
8.
That would work great, but then you got to do another step after that.
But
so
shall we go through the steps so in case some
let's
other
go through this
people
step.
are...
Okay, let's go through this step because I'm
6 and 2.
Well, no, because 6 and 2 don't have either one of them being a perfect square. But your 9 and 8 are good.
6 and 2 does not... 6 times 2 does not give us 72. So
Right,
we have to always make
right.
sure that when we multiply these two,
Yes.
they total up to the number that we started underneath our radical sign.
Well, I'm so glad Rashawn picked a 9 because square root of 9 is what, Rashawn?
Square root of 9 is 3.
Mm-hmm. So that comes out of the radical. But see, we still have one more step to go with because what number's inside of 8 is a perfect square?
Oh, is 4 the perfect square?
I love your style, man. You are so good. So we're down to this level. And we're just going to erase some old work we have. Look at Miss Davis is energized, like the Energizer Bunny. I'm telling you. And here we go. X equals, and I hope you see the old number we have here before.
Yeah.
And now you said X equals 3 radical 4. And what's the other number we're going to put in here? 4 times what?
2.
Mm-hmm. And the 4 comes out as what? Radical 4.
As 2. Square root
Right.
of 4.
Equals what? I'm sorry. Square root of 4 is what? I'm sorry.
The square root of 4 is 2.
Right. So that comes out as 3 times 2, radical 2. And what is 3 times 2?
Okay, so would the answer be 6 times the square root of 2?
Perfect. Now here's a shortcut I wanted to go through previously. Remember we were back here at this level? So let's go ahead and put that down again. X equals square root of 72. And what I like to tell my students is sometimes the easiest thing to do is start at the lowest number. What's the lowest number besides 1? What's the next number after 1?
What's what in 1?
More than 1. Go higher. 1 times 72.
A factor of 72.
Right.
So
Then
what number?
2 times what? You know?
36.
36. So you know what? 36 happens to be a perfect square. And which one comes out? The 36 or the 2?
Oh, so then that's the faster way to get to 6 times the square root of 2.
Absolutely right. And there you have the same exact
Are you
answer.
going to go over the half of 12?
Oh,
and that will automatically give you.
Yes. So if you get back to the regular original thing, why don't you take it over right now? Because you know your stuff really well, Ms. Davis.
Okay, so another way that we can think about this is that these two numbers have to be the same. So if I take half, this will always work out when we have a special right triangle that's 45 degrees. If I take half of 12, what number do I get?
6.
6. And because I have two sides right here, this side is going to be 6 on the square root of 2. Both of these.
Ah, that's what I was going to go for. That's great.
So we have gone over this problem multiple ways, and you notice that each way that we came up with the solution, it was the exact same solution, 6 on the square root of 2. So multiple entry points for your mathematics. Did that help, Raysan? Did that help?
Oh, can I do a challenge?
Do you understand how to do the problem now?
Oh, he wants to do the challenge, he said.
Oh, yes, I know how to. Yes, I know how to do it.
Okay. And you would like to do a challenge? Okay.
Yes, please.
Okay. Which challenge would you like to do?
I'd like to do challenge A.
A. 1, 2, 2, 7.
All right, let's take this real fast. We got a lot of callers waiting right behind him. 1, 2, 2, 7. All right, Rashawn, give us your best shot fast.
Okay, 7 minus 1 is 6. 6 times 2 is 12. 12 times 2 is 24.
Rayson, you have met the challenge. And there was another caller earlier working to persevere and solve that particular problem. Your name is going into the treasure chest a second time because we treasure all of our callers.
Oh, we treasure. I like that.
We treasure all of our callers that call at Count on Us.
Next caller is Isaac, right to Miss Davis.
Isaac, how are you?
Good.
And Isaac, can I ask you to turn your television all the way down? You can even mute it and listen to us through the phone, please.
Okay, I did it.
Oh, thank you so much. I appreciate it. Isaac, can you tell us what grade and what school you go to?
Can you repeat that?
Okay. Isaac, what school do you go to?
Catherine T. Reed.
All right. Well, please tell all of the teachers and staff at Catherine T. Reed we said a great big hello. And what grade are you, Isaac?
Third grade.
Third grade. Okay. And what are you working with?
Area perimeter.
Area and perimeter. Okay. Can you give me your problem that you're working with?
Okay. First, we write 6 and 3, and we're going to draw a bird. By the side is going to be 3, and when you go down, it's going to be 6.
Okay, like that?
No, on the other side.
Okay, so I've mixed up the sides.
So
this side is 6 and this side is 3?
No, put that, yeah.
Okay, so... Okay, so it looks like this.
Yes, and then you draw 3, and you draw 3, then you draw 3 by the side.
Okay, like that?
No, but you're going to have to draw 6 too.
Okay. 3 right here, and 6 right here. Okay, let me see if I can...
Oh, I get it.
If I can do that. Okay, so we're going across 6. So...
Oh, nice.
Okay, so now do I have 6?
Yes.
Okay, so let me double check. 1, 2, 3, 4, 5, 6. And this is 1, 2, 3. Okay, so are we finding the area or the perimeter or both?
Both.
Both. Okay, so what do you know about how you find what does the area of a shape mean?
It means the area of the shape will do 8 equals length times width.
A equals length times width. So why did I draw all of these little squares?
We're going to have to do something with those numbers.
Okay, so the area is the inside of the shape, the number of square units it takes to fill it. So if I count all of the squares, I will get a total of 18, which is the same thing as 6 times 3 equals 18, and my writing is absolutely atrocious. Units.
Yeah.
Okay? And we would get the exact same thing if I multiplied. So to find the perimeter, we're talking about the distance around. So I have 6 and 6.
So this one, so to find the perimeter, we'll do P equals 6 plus 3 plus 3.
Yes, absolutely.
Exactly right. You add up all your outside measurements.
So 6 plus 6 is 12. 12 plus 6 plus, 3 plus 3 is 6. So this will also give me
18.
18. So this particular shape has both an area and a perimeter of 18. 18 units here. And 18 square units here.
Well, lucky for Isaac, we can get his name right.
Isaac, your name is going into the treasure chest.
And since you're so lovely, Miss Davis, I'm
we would
shaking
like
the
to say
treasure
thank
chest.
you to all of the callers who have called in.
I'm making it happen for
we appreciate all of you. Remember,
stuck
each Monday and
I don't know
Wednesday,
how that got stuck up there.
except for a school holiday, you can join us here for your math homework.
Oh yeah, you can't call back till next Wednesday.
So our winner is Rose from C.T. Reed. Remember, each Monday and Wednesday you can join us here. Your elementary show from 4 to 5 and your secondary show from 5 to 6. Remember, you can always count on us.